Molecular scissors. So what is the purpose of the scissors? If you want to cut a paper or a cloth or a thread anywhere at a specific point, scissors comes to your help. Now type 2 restriction endonucleases act as molecular scissors because you are going to use this to cut DNA at specific points. Type 2 restriction endonucleases allow you to cut DNA molecules at specific points. Okay, so let us look at type 2 restriction endonucleases in more detail. They are very important for recombinant DNA technology work. And type 2 restriction endonucleases, they recognize and cleave the double-stranded DNA molecules at specific sequences which are 4 to 7 base pairs long. They recognize they recognize 4 to 7 base pairs long sequences, and they also cut this DNA at the same point. So this is the beauty of restriction enzymes type 2. Whereas type 1 and type 3, what they do is, supposing if they recognize this sequence here, they move away from it and then they go and cut the DNA. Whereas type 2 restriction endonucleases, if they recognize this sequence, they're going to cut it here. So they are very, very specific in their action, and therefore they are used as molecular scissors. So let me give you one of the examples of type 2 restriction endonucleases and then explain to you its action. For example, let us take EcoR1. Alright, we'll understand how they are named. Alright, EcoR1. E stands for the first letter of the genus name of the bacteria, Escherichia. Alright, CO stands for coli. That is the first 2 letters of the species name. R is the name of the strain. Okay, there are different strains of bacteria available, and this one has been taken from R strain, and this is Roman number 1, alright, where 1 is the order of discovery. In the sense, this was the first endonuclease that was discovered in this particular bacteria, so it's called 1. Afterwards another one was discovered, it was called 2. Okay, so how is it named? The first letter of, it starts with the first letter of the genus, then the next 2 letters of species. If there is any particular strain name, it is then given to it, and then comes the order of discovery. This is how it is named. Alright, now EcoR1 recognizes the sequence called GAA-TTC. Alright, GAA-TTC, I just wrote that as an example previously also. Now this goes from 5' to 3'. Endonucleases can only identify and cut double-stranded DNA. So if I write the complementary sequence from here, it goes as CTT AAG 3' to 5'. Alright, now this is the sequence, DNA sequence, which EcoR1 recognizes. Now if you look at this, the sequence is about 4 to 6 base pairs long. Sometimes it's also 7 base pairs long. And the other thing is, it is palindromic. What is the meaning of palindromic? The sequence reads the same from both the ends. You look at this, GAATTC, GAATTC. So from both the ends, it reads the same. So this is called as a palindromic sequence. So type 2 restriction endonucleases recognize such palindromic sequences only. Alright. So this is about the enzyme called EcoR1. We just saw how to name the restriction endonuclease and also a sequence that it recognizes. So it recognizes this sequence and it cleaves the sequence at this point. Alright, we will be taking up the action, more about the action of the endonucleases in the next video. I hope you have understood these points today, especially the role of restriction endonucleases. Alright, the role of restriction endonucleases in bacteria. As I told you, there are 2 roles, and also the naming of the bacteria, naming of the restriction endonuclease, how a restriction endonuclease is named, and also the definition of restriction endonuclease. Thank you.